Good morning. My name is Cody Benkelman, and I am a product manager with the raster imagery team with Esri here in Redlands, California. Joining me today is Vinay Vishwambaran, who is a product engineer, also with the raster team here in Redlands. Welcome to Working with Imagery at ArcGIS 10.1. This first slide provides a very simple outline of what we'll cover today. I'll discuss both local imagery as well as image services, and we'll spend some time covering the Mosaic dataset, which is central to many features regarding both using and managing imagery in ArcGIS. At the end, I'd like to do a quick review of some of the content on ArcGIS Online, both current and what's coming in the near future. I'll be doing live software demos with time for questions and answers, so please feel free to enter questions into the chat window at any time. I'd like to begin by confirming who are we presenting this for, so the audience can determine if this material will be helpful. In general, today's presentation is appropriate for people who have worked with ArcGIS and have a general understanding of imagery, but perhaps are not imagery experts and may not have worked extensively with version 10 and or 10.1. So this is generally an introduction to the current features and functions related to imagery in 10.1, but we will not have time to go deeply into technical details. I want to begin with a few high-level ideas to define the landscape. First, geographic imagery can be used in several different ways. In the simplest case, many people are familiar with seeing imagery as a background, simply to provide context for other information such as traffic maps or business locations. The next bullet, image interpretation, refers primarily to human interpretation. So an example would be manual feature extraction, such as digitizing roads or the boundary of a wetland. Finally, computer analysis has become more widespread, and this includes functions such as multispectral classification, or perhaps terrain analysis to identify locations to drill for oil. A second issue is the question of where is the imagery and how do I access it? First is data stored locally, meaning either on your computer or your local network. We also want to discuss image services via the internet, because this is a mode that many people are now using imagery. Note that either type of access can refer to a local private network. So in the first case, I've called it file-based access, since that is typically how we think of and organize the data, one file at a time or a group of files. But with image services, the software simply connects to an endpoint, and users work with the data primarily as a function of geography rather than file by file. We'll come back to defining and discussing image services in further detail. Finally, the third topic refers to the question of what software and hardware am I using. In addition to desktop software, we've all seen the expansion of using imagery in web applications in a browser, and of course now there is an explosion of usage in mobile devices, both tablets and cell phones. Note that the references to web and mobile applications may only be of interest to some of you if you happen to be producing outputs used in those modes. But for today, I'm going to focus just on ArcGIS Desktop and return to the other topics above. So let's begin working with local imagery. This slide is just to be sure everyone understands the variety of data applicable to this seminar. In much of the ArcGIS literature, users will find references to raster data, and that differentiates from vector format data, that is, points, lines, and polygons, because in the early days, Esri's GIS software did not process imagery. Of course, that changed many years ago, and you may still see the terms raster and imagery being used interchangeably in our literature. Going further, note that raster image data includes many types of data that did not originate as a photograph from a camera. Elevation data, for example, is stored and processed as raster imagery, even though it is not fundamentally an image. Other examples include images that come from a scanner or raster format files created from other data, such as land classification maps. I presume that those of you listening today are comfortable with all of these terms, but if not, we can refer you to more background material. So now let's look at one of the specific menus in ArcGIS Desktop. This is the image analysis window, which has collected many important imagery tools into one location. This was introduced at 10.0 and enhanced in version 10.1. In many cases, the functions on this window were already available within ArcMap, but in some cases required multiple mouse clicks and multiple menus to find and apply them. On the left, the graphic shows the image analysis window from version 10.0, so it's changed slightly. But here you'll see three sections: the list of layers at the top, and then the tools for display and processing. The display section has tools for image enhancement that can help with image interpretation. These allow you to change brightness and contrast, compare two images, and perform some other functions. In the processing section further down, you can apply a number of functions such as clipping out a region of interest, applying a vegetation index, creating a difference image, etc., even orthorectification. There are too many functions to discuss in detail, but I'll demonstrate a few of these soon. Then, in version 10.1, we added a new section in the image analysis window titled Mensuration, and this is for making vertical measurements in your imagery. And I'll come back to this part of the window. I also want to highlight raster products, which is something new that was added in version 10.1. Raster products are available for most of the common satellites and rely on information stored in standard metadata files to provide the users with predefined band combinations and more intuitive labeling in the table of contents and in the ArcGIS catalog windows. Okay, so let's switch to ArcGIS Desktop for a demonstration. What I'd like to do first is go to my last topic, which was the raster products. So how do we find those and how do we use them? What I have in this folder is a satellite scene from the Iconos satellite. And when I open this folder, what you'll find are multiple files in TIFF format that store the various spectral bands, the blue, green, near IR, and red. And then there's a fifth TIFF file, which is the panchromatic band. But rather than work with those individually, let's look at this new symbol which shows the small satellite. That is the raster product. If I open that, what this says is that ArcGIS recognized the metadata and has pre-configured these views. So we have the multispectral view, the panchromatic view, and also a pan-sharpened view. If I load this multispectral view, what we'll see is an area around Portland, Oregon. So let's zoom into the downtown area. What you'll notice immediately is the default view is true color, red, green, blue, but I can click on the individual color chips and change to a different spectral band if desired. So this is some of the more intuitive labeling I was referring to from the raster product. Now if I zoom in further, we can see this is 4-meter data. It's actually very good quality data, but at some point we begin to see the limits of the resolution. If we'd like to see more detail, I can drag in the panchromatic view, which is a 1-meter image from the same satellite. And ideally, if we could combine the resolution of the the resolution of the panchromatic with the color from the multispectral, we might be able to see even more detail, and that is what the pan-sharpening view does. It actually fuses the information from the panchromatic band with the color information from the multispectral bands. So those are the views pre-configured by the raster product. Okay, let's go ahead and go now to the image analysis window. We call that up by going to Windows, then Image Analysis. And what you'll see here are in the upper section, the table of contents is reproduced from the left side of ArcGIS Desktop. And the way I use this is to click on an image first and then apply a function. So if I click on my pan-sharpened view, then we now have these sliders that allow me to change the contrast and brightness and even the gamma, which is a nonlinear adjustment. But if we get the image to a state we don't really like, I can use the buttons to reset to the original values. We've also added the histogram interactive stretch tool. So if you like to look at histograms when you're making these brightness and contrast adjustments, we can actually see the histograms on screen as well. But again, that's only for 3 bands at a time. And remember, when I'm making these adjustments, I'm not changing the data. I'm only changing the view in the map. Okay, let me go ahead and reset those back to the original values. So in addition to the visual enhancements, we've also got the processing functions in the processing section of the image analysis window. And what I'd like to do here is, I'll skip over most of these at this point, but I'll come back to these in a later demo. But I'd like to go ahead and move down to the mensuration section, which was added in 10.1, and see if we can measure the height of this building in downtown Portland. If I take this center tool and click from the bottom of the building to the top of the building, I can get a pop-up that estimates the height at 169 meters. Now, this is relying on the image metadata that comes from the Icono satellite. And so this functionality is not available for all imagery, but only if there's appropriate metadata. And we can provide further detail through our help system if you're interested in that. There are a couple of other buttons here just to highlight very quickly. You can also measure from the top of the building to the top of the shadow, or you can measure from the base of the building to the top of the shadow. That's a bit difficult in this complicated urban environment, so I won't do that today. Okay, so that's what I wanted to show for the first demo. Let me go back to the presentation, and we'll continue with some of these concepts and come back to another demo. We looked briefly at using local imagery, so now let's transition to image services, which allow users to connect to a single endpoint and obtain imagery for any area of interest. And then the user can simply zoom and roam. Note, I may say the internet, but remember, image services can be used on private networks as well. There are different methods of sharing imagery via a network. The one that most consumers are used to seeing is what is technically referred to as an image cache. The cache takes a static image. Some people also call it background imagery or wallpaper imagery. And it cuts that image into tiles of fixed size with known boundaries and builds a pyramid of reduced resolution images. This is typically done in the Web Mercator projection, and it's the fastest method for delivering imagery. But note, the images don't change unless the cache is updated, and that can be time-consuming depending on the size of the image dataset. This is all pre-built and very fast, and it's the method used for the common mapping applications, ArcGIS Online, as well as some of the others you're familiar with, Bing Maps and Google Imagery. And it's again, the fastest method for serving imagery because the server only has to know the location and the resolution of the imagery, and then it simply looks up the tiles and delivers them, usually in a compressed JPEG format. But if you want to do any sort of analysis, you may need more than that background wallpaper imagery. Dynamic image services also allow users to access the image data they're seeking by connecting to a URL. So the imagery is available immediately and simultaneously to a wide range of software clients using different hardware and software platforms. Dynamic image services provided by ArcGIS for server software allows the user to look at a variety of different views of the data, depending on what range of data is available. It could be multiple overlapping views from different sensors or different perspectives, and possibly different dates. In the case of multispectral imagery, dynamic services allow the users to see all of the spectral bands, not just a single red, green, blue view, as I showed with the Portland imagery and changing in the table of contents. Users can also access the full dynamic range if the imagery is greater than 8 bits per pixel, and this can be very important for interpretation or analysis. Of course, there are a lot of configuration options. The organization serving the imagery may choose to limit some of these features, but the key is that the full range of imagery is available. Okay, let's return to ArcGIS Desktop and do a further demo. Let me go back to my panchromatic view and zoom out. And what I'd like to do is go to ArcGIS Online and add a base map to show some context. I had mentioned that this is Portland, Oregon, but if we add this Bing Maps hybrid image, we can see some imagery and also a map overlay that will give us a bit better context on where this imagery is located. And note, this is coming live over the internet, so the first time we load it, there may be a bit of a delay in getting that base map to show. But let's say I want to do I'd like to do some interpretation, and for sake of argument, perhaps I don't have the multispectral imagery. Here comes my base map. There's my base map. So again, this is an example of the cached imagery that I was describing. But let's say it's my job to do some image interpretation, and I don't want to use this base map because I don't know the date of the imagery. But I've heard that the USDA is hosting some imagery from its National Agricultural Imagery Program. The acronym is NAPE, and you'll hear me say that a few more times. So we're looking at a USDA web page, and if we scroll down, we'll see that USDA is actually hosting imagery on a server that you can add into ArcGIS Server. So I'm going to copy that URL and go to Catalog and scroll down to the GIS Servers section and add ArcGIS Server. So if I paste that URL into this menu, now ArcGIS Desktop can connect to these services. And note here there's an opportunity to add a username and password, which is required for some services, but in this case we don't need a username or password. So this new server has appeared in my list of available images, and if I open this NAPE folder, what you'll see is there's essentially a separate image service for every state from the NAPE image program. And note that this is 2012 imagery from the Oregon NAPE program. So I'll zoom out to this full data set and show what we're seeing here. If I turn off the base map, what we'll see is the entire state of Oregon coming from that NAPE image server. And so again, none of this is local imagery, but it's coming live over the internet from the USDA. Now let's say my job is to delineate some wetlands. So I'll zoom into this area where I know there's a wetland on the Columbia River, and I'll turn on my drawing toolbar once that zoom refreshes. And what I would like to do is digitize a polygon around a wetland from the NAPE imagery. So let me get a polygon started and click around this, and again, note that this is all based on the image service that I've acquired from the USDA, so none of this is local imagery. So there I've clicked around my wetland, and I'd better check my work, so I'll go to some imagery that I've downloaded from the National Wetland Inventory Program. If I drag that into the map, you'll see the polygons that have been previously digitized. It looks like I did an okay job, so I'll zoom in and let me select my polygon and make it transparent so we can compare my work to the previous work. I'll change the boundary of this so it's a little bit easier to see. And it looks like things may have changed a bit relative to the NAPE imagery versus the polygons that I downloaded. One other thing I'd like to show is, since I do now have this polygon, if I go back to my multispectral imagery, I'd like to clip out this polygon, this wetland, for a report that I'm doing. So I'll select that multispectral imagery, go to the processing section, and then use this clip function, which clips based on the currently selected polygon. So if I turn off my other imagery, what you'll see now is only the area that I've clipped out of that multispectral image. I'll delete my polygon, and if we want to save this, now this image is only in memory, but if I want to save this image, I can right-click and export that data and save a local TIFF file or any other of the formats that ArcGIS supports. I can save as a local copy to disk. So I think that's all I wanted to show in this section. Let me verify my notes. Okay, let's go back to our PowerPoint presentation. I think we may have received some questions, so let's take a moment and ask Vinay if we've gotten any questions about accessing either local imagery, image services, or cached versus dynamic.
Vinay? Yes, we have quite a few questions. So we start off with a minute out of Portland. His question is, does image analysis window work with cached services? The image analysis windows, it does not work with cached services, and it does not work with the base maps. Now, a workaround for this, if you really have to work with your cached services, or if you'd like to make modifications to your image service or map services, you can ingest your map service or image service into a Mosaic data set and then process the Mosaic data set using either functions or using the image analysis window. Now, Cody will be talking about Mosaic data sets in a little more detail further down. Next question is from Jeffrey out of Arcata. How do you make the pan-sharpen imagery from the panchromatic and multispectral imagery? Is there a tool that can combine the panchromatic and multispectral to produce the pan-sharpened data? You can use the image analysis window. It gives you one-click access to the pan-sharpen functionality. The resultant imagery can then be easily output, as in exported, as in you could just right-click on the layer, hit data, and export, and there you have your pan-sharpened imagery. We also have the Create Pan-Sharpened GP tool, which lets you pan-sharpen imagery. Now, if you pan-sharpen using the image analysis, this is done on the fly. Likewise, you can use the pan-sharpened raster function within the Mosaic dataset and process a whole collection of images using a Mosaic dataset. Our next question is from Dave out of Clinton. Is there a way to predefine different raster product combinations? Raster products are built off of the raster types, and the different so-called combinations are essentially templates as defined by the raster types. Raster types are specific to a sensor, and you can write custom raster types and processing templates using the SDK that's provided. We have different samples as well that's available on the Resource Center. Cody will be pointing to you further down. He'll be talking a bit more on raster types as well a little later. Our next question is from Dermus out of San Antonio. What about LiDAR data? Rather vague question, but I'm guessing you mean how do we handle LiDAR data in 10.1? Well, LAS files are natively supported in the Mosaic dataset. When consumed, it's rasterized on the fly. You can switch between different returns and different classes on the fly. Now, the anatomy of the Mosaic dataset will be explained further down. You can ingest LAS files into a LAS dataset as well, which lets you work interactively with your LAS files. The LAS dataset essentially is just a LAS-specific container. The next question is from George out of Austin. How can I enhance a collection of images using the interactive stretch window that's located on the image analysis window? So we've added the option to enable you to select multiple rasters and quickly perform tasks such as gamma change, contrast, brightness, convolution filters, etc. Changing the stretch, however, is largely dependent on the histograms and statistics of each image. So you really can't do that as each image is different. One workaround, though, is use the merge function on the image analysis window. This creates a raster which you can then process or work with like you would with a single image. Now, this solution is feasible for a really small collection of images, and my recommendation would be load everything, especially if it's a larger collection, into a Mosaic dataset and then process the imagery as a whole. Next question is from Jennifer out of Auckland. Are there restrictions when working with imagery of different formats or bit depths or bands using the image analysis window? The image analysis window, it works with a whole range of imagery bit depths. It includes signed, unsigned, complex data, 11-bit data, 12-bit, 16-bit, 64-bit imagery as well. You can directly create function rasters and convert bit depths as well. And when working with a map cache, big maps, for instance, like I mentioned already, you can't really do any operations using the image analysis window. Next question is from Jonathan out of Ohio. Every time I load my imagery into ArcMap, it stretches the imagery. This is good, but I don't want this to happen in case of my pre-processed imagery. We have a flag in the Mosaic dataset, but is there an option we can choose specifically for a raster? So we have a feature we've added in 10.1. You can right-click on your raster in Catalog, hit Properties, click on the General tab. You should see a Source Type option. You can change that to Processed, and that should solve your problem. And that's all I have for now. Back to you, Cody, again.
All right. Thank you very much, Vinay. Keep entering questions. We've got 2 more Q&A sessions coming up. Okay, we've talked a little bit about the different usage modes of imagery, and we've looked at working with single imagery, but what if you have large collections of imagery? On this slide, what I would like to do is emphasize the scope of the challenge for both users of image data and also data managers when you're dealing with large imagery collections. Data can come from a variety of different satellite or aerial sensors, and it can represent many different data types, as we've mentioned. And the different types also imply a variability in the number of spectral bands, the bit depths from 8-bit integers to 32-bit floating point values, and further variety in the associated metadata. The imagery also can arrive in various different processing states, either raw data direct from a satellite or aerial camera, processed data that may already be orthorectified, or the static image cache that we've discussed. There's even more variation that is not shown on this slide because data comes in different projections and typically will arrive one project at a time, so you may have multiple project areas acquired at different times. So the breadth and depth continues to expand rapidly. So the question is, how do we manage and work with all of this variety? The solution within ArcGIS for managing these issues is the Mosaic dataset. That's the data structure that we recommend for accessing and working with imagery in ArcGIS. It was originally introduced at 10.0 and enhanced in version 10.1. The Mosaic dataset serves imagery as an image library or a catalog with pointers to the original source image files. So when we say references source image data on this slide, the key is that the imagery is not ingested into the Mosaic dataset. We're not copying or reformatting large volumes of imagery. We're simply referencing the imagery in its original format. Now, the Mosaic dataset does store key image metadata and can also define processing rules. The Mosaic dataset is stored in a geodatabase, so it can be very, very scalable for many, many users and very large datasets. Esri has recently published image services with Landsat data, including more than 2 million records in a single Mosaic dataset. And if time permits, we may have time to show that in a later demo. The authoring and management of the Mosaic dataset is done through ArcGIS Desktop, but users can access the data using other software. It's accessible as a virtually mosaicked image, which is processed only when the view is requested, and I'll discuss the dynamic processing in the next few slides. Users can also query the Mosaic dataset as a catalog to find footprint geometry for individual images, look at metadata, etc. And finally, the Mosaic dataset can be accessed as an image service, as we've discussed. One of the terms I want to introduce is the raster type. This was introduced in version 10, and I want to provide a bit of detail to make sure it's clear. What ArcGIS calls a raster type is a set of templates used to add imagery into a Mosaic dataset. It's specific to a product, either from a particular sensor, like Iconos, which I've just shown, or many of the other satellites. Alternatively, it may refer to a specific file format, such as NITF, and the associated metadata information that is necessary to properly configure the Mosaic dataset. It addresses details such as the file format and organization, georeferencing, spectral bands, metadata such as acquisition date, etc. Basically, as much information as possible for every available raster type. And it's very important to emphasize that raster types can be customized if you have unique sensors or unique data formats. The SDK is our software development kit. So there are many features and details of the Mosaic dataset, but the two high-level concepts I want to introduce are dynamic mosaicing and on-the-fly processing. I'll address these separately in further detail, but dynamic mosaicing refers to building a single image view from many input images, and furthermore allowing the user to change that view if desired. On-the-fly processing refers to the ability to apply processing to the imagery when they're accessed. So it's more than simply reading imagery from a disk and putting it on the screen. I'll come back to the on-the-fly processing, but let's look at dynamic mosaicing. What this means is that the composite image seen by the user can be changed to show different images in the regions where images overlap. The Mosaic dataset is generally configured to show whatever you would consider the best available or the standard imagery to review by default. But the ability for the client software to change image service or Mosaic dataset properties enables a user to see and do more with the available imagery. By changing what we call the Mosaic method, the user can define priorities in image order. In other words, which image appears on top. So, for example, images can be put into a time sequence and show either the oldest or the newest imagery, or prioritized based on an attribute, such as cloud cover. Or in the image examples I've shown here, a view direction to take advantage of oblique views of the same location on the ground. At the bottom, I also refer to the ability to do a query using the Mosaic Dataset Catalog and select available images from using multiple attributes, and then we can either look at individual images or build a mosaic view of those selected images. Okay, let me go back to ArcMap for another demo. And in this case, what I'd like to do, let me get rid of my clipped image. What I'd like to do is just walk you through the actual creation of a mosaic data set. I had mentioned this one satellite scene that was comprised of 5 separate TIFF files. I've actually got 8 images, 8 scenes from the ICONOS satellite, and what I'd like to do is put those all together into a single mosaic data set. I start with a geodatabase, and then right-click and add mosaic and create a new mosaic data set. So in this case, I'll just call it LTS. And I need to define the coordinate system that I'd like to manage the mosaic data set. I typically use this Web Mercator projection because that's compatible with all the common mapping software. But this is not necessarily the projection of the image data. So this is only the projection that I want to manage that data in. And in fact, this data is in a geographic projection. So ArcGIS will do the projection on the fly. So what I've done so far is simply create an empty mosaic data set where I can store my data. Now let's go to back to catalog and say add rasters. And for generic imagery, say GeoTIFFs or JPEG 2000, we can use this generic raster dataset raster type. But I had talked about the importance of using the proper raster type. So in this case, we know we're looking at imagery from the ICONOS satellite. So by selecting this raster type, it informs the software where to look for metadata and properly configure the mosaic dataset when I bring these images in. So now I'll select the 8 folders with those 8 satellite scenes and tell the software to add those into the mosaic data set. And what it's doing now is simply reading the metadata. Again, it's not copying or reformatting any of the imagery. It's simply reading the metadata to build this mosaic data set. Now if I zoom out to look at this full mosaic data set, what you'll see are the footprints of the various satellite scenes. And if we want to see imagery at small scales like this, we would need to follow another step, which is referred to as building overviews. But in this case, what I'd like to do is simply look at the attribute table and look at the metadata that was ingested using that ICONOS raster type. So what you'll see is by knowing the raster type and the metadata format, we can identify the sensor and other metadata for this imagery, such as the acquisition date and time, information about the position of the satellite relative to the sun, and that's important for some of our other advanced features. There's even metadata regarding cloud cover, so we can sort and hide the cloudier images if we would like. Okay, what I'd like to do now is zoom into this area where I know I've got multiple overlapping images and look at the dynamic mosaicing. So in this case, I'm looking at one image. If I go to the table of contents and select visible rasters, now I go back to the footprint table and see which of those rasters I selected. This button will hide those that are not selected, and now I can scroll to the right and look at the acquisition date. So this satellite image came from 2003. Now I know I've got overlapping images here, so let me go back to the table of contents and go to Properties and go to this Mosaic tab in the Layer Properties. What I want to do is change this attribute or this function called the Mosaic method, change and mosaic according to attribute, and now it populates with attribute values or attribute labels out of the attribute table. I'd like to select the acquisition date, and I'm going to use an ascending order so I can look at older images. So if you watch this image in the map when I hit apply, you'll see it will change slightly. I'm actually looking at a different image now. So if I go back to the footprint table and select visible rasters, what we'll see is this acquisition date will change. This image that I'm looking at now actually came from 2002. Okay, so that shows just a very quick introduction to the mosaic method and the dynamic mosaicing. And I want to remind everyone that we're focusing on ArcGIS Desktop, but other client software can still control this mosaic method. So this is not exclusive to ArcGIS Desktop as the client software. That's all I have time for in terms of this demonstration. Let's go ahead and move on. And we've talked about dynamic mosaicing, but now let's talk about on-the-fly processing, because this is a very important and exciting feature of the mosaic data set. The important thing to note here is that images can be left in their original format on disk and then quickly processed when requested, so only at the time of need and the area of interest is the imagery processed. Now, the processing can include a great many different functions. I've only listed a few examples here. For example, the client can specify the projection of the imagery served. So I'd talked about using the Web Mercator projection and accessing geographic imagery, but if the client wants to see the data in UTM, then ArcGIS can reproject that imagery on the fly, regardless of the original input projection. The client can also control compression, which can speed up the view when you're roaming around, and then increase detail when you find the area of interest that you want to look at. The client can also control resampling method, and again, these are just a sample of the full list of parameters that can be controlled. The on-the-fly processing capability also means that many different products can be generated from the same set of imagery, but again, only processed when needed. ArcGIS has a long list of image processing functions that can be applied, including histogram stretches, spatial filtering, and many, many more. What I'm showing in this diagram is just sort of a visual concept of combining multiple images into the mosaic data set. In this case, if we're looking at the NAPE imagery, the default view would be true color. But there's another function that is referred to as the referenced mosaic data set. And this is where we can actually make a read-only copy of a mosaic data set. And then raster functions can be applied to those referenced mosaic data sets. And in the example I'm showing here, I'm extracting a color infrared view using a function coming from the 4-band NAPE imagery. I can also extract a band ratio that some of you may be familiar with. It's referred to as the Normalized Difference Vegetation Index, or NDVI, and this is just a method of highlighting vegetation. There are other processes, of course, such as orthorectification and pan sharpening that I've already mentioned, and these are all applied on the fly, and this presumes, of course, that the appropriate data is available. And note these functions can be chained together, so the software resamples the imagery only one time from the source imagery direct to the output product. And now what I'd like to do is change the view in the bottom, where I'm looking at input data that's raster elevation data as opposed to optical imagery. And in this case, the functions I'm applying are a hillshade function and a slope function. So again, remember that these different views are not pre-calculated and stored to disk as separate data sets, but are calculated by ArcGIS only when these views are needed. So this shows the user interface for applying those raster functions. I just showed examples of band combinations for the NAPE imagery and a hillshade and slope, which you can see in this menu. But note there are many, many more functions. Also note, raster functions can be applied not only to the mosaic data set, but to individual rasters in the mosaic data set. I have an example where I've worked with elevation data, and the input data is LiDAR-derived data that's measured in feet, and I used a raster function to rescale that data to meters so that it matches the other data in my multi-source mosaic data set. And as with the raster types, note that custom raster functions can also be created if necessary using the software development kit. Okay, so let me go back to ArcMap, and for this demo what I'd like to do is zoom out, and instead of looking at the imagery, I'd like to look at some elevation data that I've compiled for this area around Portland. And this elevation data that we're looking at is actually 32-bit floating point values. So if I go to the top of Mount Hood and query the image layer, I can get an estimate for the top of the mountain. So the top of the mountain there, or near the top, is about 3,115 meters above sea level. But if what I'd really like to see is just a hillshade, what I'd like to do is now go to the mosaic data set in catalog and create a referenced mosaic data set. Now note that this will always put my mosaics into the default geodatabase, so I'm going to copy that string and make sure it goes to the same same geodatabase. I'm going to name it hillshade, and what we'll see is a read-only copy of the elevation mosaic. So it's loaded it into the map, and what we're seeing is the hillshade, or I'm sorry, we're seeing the reference mosaic data set that I called the hillshade, but so far I'm still only seeing the elevation values. So now I'll go to the properties and this function tab, right-click on the mosaic and insert the hillshade function. I'll accept all of the defaults except this scaling value. I'd like this to be adjusted as we zoom in and out to different view scales. And I'd like to highlight very quickly the elevation data that's being processed is 32-bit floating point values, but the output of this hillshade is just an 8-bit unsigned image, so we can actually compress that for a faster view. And so now the hillshade that we're seeing is created on the fly from the elevation values. So none of this hillshade is pre-calculated. It's only created as ArcGIS zooms and roams to the underlying elevation values. And one other point, remember that the reference mosaic data set is a read-only copy, but it is a live connection to the master mosaic data set. So if I was to add new elevation data into the parent mosaic, it would automatically appear in this hillshade and any other reference mosaic data sets. So just very quickly, let me go back to look at the Portland data and call up that properties menu one more time. This is the Iconos imagery. If I wanted to insert another function here, I could insert the NDVI or the pan sharpening function. So there was a question about pan sharpening. So it can be applied through the image analysis window, but it can also be applied as a function in the mosaic data set. Okay, I think we're running out of time, so let me go back to Vinay and see if we've gotten any more questions now about mosaic data sets, dynamic mosaicing, or on-the-fly processing.
Thank you, Cody. We have a lot of questions, and to start with, we have 3 questions which are asking us. They're all asking us, what's the NAPE URL that you just showed them, a demo of the NAPE imagery. So probably once we're done with the Q&A, or probably towards the end, you could show them the URL. Oh, there you go. It's on screen right now. The next question is from Minot out of Portland. Can different raster types be added to the same mosaic data set? And a similar question from Joseph out of Redlands. What if you want the mosaic images from various sensors, that's Iconos with Landsat, what do you specify as a raster type? So to answer both questions, like we've mentioned earlier on, you can fuse in data sets from multiple bit depths, multiple data sources, and multiple formats into a single mosaic data set. The processing and the mosaicing is all handled on the fly. As for handling multiple sensors, how is it ingested into the mosaic data set? You can use the add raster GP tool and specify the raster type. Yes, unfortunately, you will have to pick the Iconos raster type to ingest the Iconos imagery, and then you would have to pick the Landsat raster type to ingest the Landsat imagery. So that would be 2 separate steps to ingest your imagery. You could even chain it together and write up a GP model which will automate the process for you. Next question. This is from Dermis out of San Antonio. What is the reason for dropping the support for raster catalogs? Well, we've not really dropped the support for raster catalogs. It still works. You can still ingest imagery into the raster catalogs, but we're pushing our users more towards using the mosaic dataset. The mosaic dataset is the new data model for handling and managing imagery within ArcGIS. It's a lot more robust, it's scalable, and the dynamic mosaicing capabilities and the on-the-fly processing capabilities makes this really, really powerful as opposed to raster catalogs. So we've not really dropped support for raster catalogs. It's there, it's available, you can still work with it. But we'd recommend you move to mosaic datasets. And for those of you who have a lot of raster catalogs, You can ingest a raster catalog directly into a Mosaic dataset, so transitioning should not be a problem either. Next question is from Richard out of Olympia. How do you turn on the image analysis window? The standard toolbar in ArcMap does not show this tool window. You can click on the Windows menu in ArcMap, and right down there you have an option to invoke the image analysis window. That brings up the window, which is dockable, and you can dock it onto the side. Next question is from Teresa out of Corvallis. Is Dynamic Image Services new in 10.1 image server? Well, I'm guessing your question is, are image services new to 10.1? Image services have been around since 9.2, if I'm not mistaken. Yes, it's been around for a while, although previously it was a standalone extension, and it was driven by shapefiles in the image service definition. But conceptually, image services have been around for a while. It's now natively supported. Ever since version 10, it's been natively supported inside ArcGIS, and it's called the Mosaic dataset. The data model is called the Mosaic dataset. So you can publish out a Mosaic dataset, and once it's served out, you can access it as an image service. Next question is from Nilza out of Fort Worth. Does the image keep its coordinates once clipped? I'm assuming your question is, do we lose the georeferencing information once we clip an image? No, we do not lose the georeferencing georeferencing information. The coordinate information and the spatial reference information are both stored within your imagery. Next, we have a question from Natarajan out of Manama. I have ortho photos of 2010 and 2012. I want to fuse these two sets together on the fly. Is it possible? Yes. Just like I've responded to Minnow and Joseph earlier on, you can fuse in data from multiple sources, multiple sensors, bands, bit depth, formats, all into a single Mosaic data set, and it's handled seamlessly and processed on the fly. And that's all I have time for right now. Back to you, Cody.
All right. Thank you, Vinay, and thank you, everyone, for sending in questions. Let's go ahead and continue with the presentation. What I'd like to do is just very briefly touch on creating image services. So if there is a need to share large collections of data, how can we do that with the Mosaic data set? One thing that was mentioned briefly, but I want to repeat, is that the Mosaic dataset can be shared on a private network. So if your colleagues are using ArcGIS desktop software, multiple users can access Mosaic datasets that are shared. And note, they can be configured to allow editing or shared as a read-only data source. For those interested in sharing with a larger community, ArcGIS for Server provides the capability to host image services. I'm only going to talk briefly about Server just to complete the story, but if anyone listening needs further detail, we have other training courses focused on Server. Now, those services can be static cache, if that meets your user's needs, or the dynamic image services that we've shown. And presuming this is a larger user community that does not use ArcGIS, they can access the full capabilities of our dynamic image services if they're using custom client software that's based on Esri's applications programming interfaces, or APIs. And note, these specs are completely open and published standards. Now, image services can also be configured for compatibility with the OGC standards like WMS, WCS, or KML. But note that not all of the dynamic capabilities will be accessible, and that will depend on the version that was used for the application. Okay, so we've talked about a lot of different concepts, and I wanted to just step back and take a moment to summarize how it all fits together with this graphic. Let's just break it down as a review. Imagery comes into your organization from a variety of sensors or data sources. In most cases, it comes with metadata that can be harvested and used to organize and manage that data. So we create a Mosaic data set that's stored inside a geodatabase, but the imagery is not typically copied into the geodatabase. The Mosaic data set simply points to the image files stored on disk. Now, depending on the file format, for efficiency, you may want to reformat the images, but in general, you do not have to. You can leave the images in their original format. Now, depending on what you're doing with that imagery, you may apply functions to generate multiple products, And then the Mosaic dataset can be shared locally to ArcGIS desktop users. If you're serving out to users on web and mobile and desktop clients, then you'll need to be using ArcGIS for Server to serve out image services. Okay, so very quickly what I'd like to do is just give you a quick overview to some of the projects that are coming and the content that's currently available on ArcGIS Online. I'm hoping that everyone listening is familiar, but if you're not familiar with the maps and data and applications that are all hosted on ArcGIS Online, I want to encourage everyone to take a little bit of time to see what Esri is offering. And remember, this is updated constantly, so we've always got new things, new maps, new imagery, new data, etc., and applications. We've hosted worldwide imagery here in the upper left for quite some time now, and we're updating that with 50 million square kilometers of imagery from Iconos at 1 meter per pixel, and this is primarily worldwide outside the United States, outside North America. In the upper right, I'm making reference to the Landsat Natural View product, which was created by a partner in the industry, and that's MDA Federal. It's a fantastic worldwide color-balanced mosaic of virtually cloud-free Landsat imagery. The lower left refers to dynamic image services based on Landsat, and that's been running for more than a year, providing full access to full resolution 7-band imagery. And this was improved and updated just this last July with a new improved image quality earlier this year. On the lower right is the World Elevation Service, which is something I've personally worked on, so I want to take a moment and give you a quick commercial about that. Here's the URL where you can get started. The World Elevation Service is web-based image services to provide users with quick and simple access to a global collection of multi-resolution, multi-source elevation data. This lists the various sources from low resolution all the way down to some sample areas that are very high resolution, including some samples from Intermap, another of Esri's business partners. This is 1.3 terabytes of imagery of elevation data served from an Amazon server or multiple Amazon servers using the Mosaic dataset and ArcGIS server. And the method we use to put all of this together is an example of best practices that we're happy to share if it's applicable to anyone who is listening. In the World Elevation Services, what you'll find are many visualizations, and of course all of these are generated on the fly, only when a client connects to these services. You'll also find the floating point elevation values in this primary elevation source. There are also other data layers, such as slope and aspect, if you want to actually query and use the slope and aspect values instead of the visualizations of slope and aspect, which are in the upper part of the slide. There's also an ellipsoidal DTM if you're orthorectifying satellite imagery. So that's a separate service that you can connect to. Okay, let me go ahead and give you just a quick view of a shaded and pan-sharpened Landsat image product. This begins with a bathymetric map. On top of that, we add the enhanced Landsat that I was mentioning. That was then fused with the hillshade from the World Elevation Services. So now you can include the hillshade within the imagery. And then we used a mask to eliminate the ragged edges around the coastlines. And this is all available. It's currently available as a dynamic service. It's being processed into a faster map cache, which should be available next week. And this is all being created with the tools that we've shown so far today. Okay, we've only got a few more minutes, so let's take another 5 minutes before we wrap up. Vinay, are there any questions about serving or ArcGIS Online?
We have quite a few questions. There are quite a few questions that are related to rasters in SDE. We have Doug from San Jose asking us the advantages or disadvantages of storing rasters in SDE. We have one which is John out of San Antonio. Should I store my data in SDE? And we have a question from Jordan out of Charlotte. I have my imagery in SDE. How do I get it into a Mosaic dataset? So Cody's talked to you briefly about raster types. Raster types is essentially used to ingest imagery or different formats and sensors into the Mosaic dataset. The intelligence to load data and understand the data type is built into the raster type. Rasters stored in SDE can be recognized by the raster dataset raster type. Simple workflow would be create a Mosaic dataset, run the add raster tool, pick your raster dataset, raster type, point it to your input SDE rasters, and hit OK. And there you go, your Mosaic dataset is ready to be consumed. Now, on a related note, to answer your questions, Doug and John, most of the questions that you guys have, if you do have your imagery stored as files on disk as well, we would recommend you point to files on disk as opposed to manage rasters on SDE. They are known to perform better, and we recommend moving forward work with files on disk as opposed to writing out your rasters into SDE. We have a few questions that are related to time. The first is William out of Norman. Does a Mosaic dataset support time-based animation? Another one is Raid out of El Paso. Is there a way to create a timeline for multi-year imagery to show changes? The next one is Dirk out of Melbourne. Can I put multiple years of imagery in the same Mosaic dataset? Yes, you can to all of this. Mosaic datasets, like the rest of ArcGIS, are time-aware, which means you can step through time using the time slider to view imagery from different dates and different time slices, using the Mosaic method and dynamic mosaicing capabilities of a Mosaic dataset. You can also sort your imagery based on acquisition date or acquisition time. Hope that answers your question. Next we have is, what is the imagery resolution while I clip the online from remote image server? Okay, I'm guessing the question, okay, this is from Waven based in Tomball. I'm guessing what he means is, when I clip my imagery from my remote image service, what's the resolution that I get offline? So you have the capability, just like the data export option off of a layer, an image service is just a layer. So you can export from an image service and specify your output resolution, and the resolution is not a restriction. You can even download the source rasters, but this is a capability that has to be enabled on the server for a specific service. So you have a choice to clip an image space, or you can, so that means you can download the original file and clip it, or you could just download the raw rasters, or you could export the raster as you see it on screen. So you have three different options to download your imagery or export your imagery at different resolutions. Next is a question from Mark out of Philadelphia. If you use raw imagery and a DEM, are control points required to properly orthorectify the imagery? As for orthorectification, we require you to provide the interior orientation parameters and the exterior orientation parameters. In case of standard frame, that would be the omega phi kappa, and the camera parameters such as the focal length, the Conradi coefficients, and so forth. All this put together, we can orthorectify your imagery. We do not do bundle block adjustment. We do not ingest control points. We do, however, work with projects such as the Match 80 project, the Info project, or the ISAT project. So you can ingest these projects directly into the Mosaic dataset. We read the information and orthorectify on the fly. Is the on-the-fly processing, the next question is from Lay and out of Bothell. Is the on-the-fly processing done on the client or on the server side? The on-the-fly processing is done on the server side. Can we use Mr. SID format in 10.1 Mosaic dataset? Yes, we can use Mr. SID in 10.1 and in the previous versions of the Mosaic dataset as well. And that's all I have time for.
You've got time. Go ahead and do
Okay.
it.
So Cody says I have time for a couple more. The next question, okay, one more. The next question is from Kevin out of Boston. Should I cache my Mosaic dataset or no? If you need to serve out your imagery collection for non-analytical purposes or as a backdrop, in other words, you really don't need the real pixel values, on-the-fly processing capabilities, or dynamic mosaicing capabilities, a cache is the best way to go. It's highly optimized and it involves just fetching of pre-processed styles as requested by a client. with no intermediate processing or sampling whatsoever. You can serve out an image service as a dynamic cache, in which case cache tiles will be generated when an area is hit for the first time. So the first access will be slow, all subsequent access to that AOI and slice will be blazing fast. So as I mentioned earlier, in 10.1 we've added a new functionality. In addition to enabling users to build an image service cache, instead of having to embed a mosaic dataset in a map service and then caching as a map service, you can now consume a single image service as either a cache or a dynamic image service cache. This is in desktop as well as through web clients. Back to you, Cody.
All right. Thank you, Vinay, and thanks everyone for these great questions. Unfortunately, we don't have time to answer all of them. Before we go, I'd like to point you to a few resources. The Imagery Forum is a forum where users can enter questions and answer each other's questions. So that's a very effective forum. The blogs are any new ideas and shortcuts and hints from Esri engineers. They're collected in the Imagery community, so I would encourage people to try to familiarize with the Imagery community. And I wanted to thank everyone for joining us and encourage you to please take a moment to complete our survey. It really helps us improve future seminars. So please click on the Give Us Feedback link to take that survey. And I hope you enjoyed the survey this morning. On behalf of Esri, I'd like to thank everyone for attending.